in this innocent looking question here, we have two methods. The first method is easier to do for this situation. The second method, you need to be a master of if you intend on handling some of the toughest questions that you're going to see on the digital SAT. So we're going to show them both ways. In method number one, we're going to just go ahead and solve and let the variables drop away. So distributing to begin with, 150x minus 90 equals negative 90 plus 150x. What you'll notice right now is that we have 150x on both sides. So if we take away 150x from the left and from the right, the variables are dropping away and it's leaving us with negative 90 equals negative 90, which is really weird. But you do need to know on the digital SAT that if the variables of an equation drop away, if you end up with a true statement, then the answer is all real numbers. If you end up with a false statement, it's no solution. So here, negative 90 is in fact equal to negative 90. So the answer is all real numbers, infinitely many solutions, and that's going to be answer choice C. But let's go ahead and discuss the other method because, as I mentioned, it's really critical for things that you need to be able to do on the SAT. And what we're talking about here is that it's actually an intersection backwards. Now, for intersections in other situations, what we usually do is we set them equal. In other words, if a question is asking you to find the intersection of two functions, then you get them both in the y equals format and you set them equal. So the idea of an intersection backwards is that if you see two things set equal, you can imagine that they were both individual functions. So in other words, looking at this equal to this, it's possible to say, well, this was 10 times 15x minus 9, and the other one is negative 15 times 6 minus 10x. And we're seeing this as split into two, we're seeing it as split into two separate functions. So cleaning up the first one, we already know it turns into 150x minus 90. And cleaning up the second one, we also know that it's 150x minus 90. And now we're seeing this from the perspective of the three ways that two lines can interact. Two lines can hit once, they can hit never, or they can hit all the time. And those have ramifications for slope and y-intercept. If they hit once, the slopes are different. If they hit never, the slopes are the same and the y-intercepts are different. And if they hit all the time, the slopes and the y-intercepts are the same. So looking at both of these, we're seeing that both of the slopes are the same. Now, by the way, if you don't notice already, these are both in the y equals mx plus b format. That's a y equals mx plus b. That's a y equals mx plus b. And by the way, we know they're identical, right? So the slopes are equal and the y-intercepts are also equal. And so that's this situation, infinitely many solutions. So whether you're using method one or method two, we know that the answer here is C.